Project 1.5, the counting circuit. In this video, I'm going to discuss the theory, components, and process behind each stage of this project. The analog input. This circuit uses a momentary push-button switch, or PBNO, and its pull-up resistor configuration. This means that normally the output is high, but when pressed it turns off. The opposite of this is a PBNC, push button normally closed, which is normally off and turns on when pressed. Second, the NAND gate oscillator. This circuit uses the 411 NAND chip. This circuit is a circuit that generates the clock pulses. It generates the clock pulses by using RC1 and RC2. The combination of a resistor and a capacitor creates these specific clock signals. Thirdly, the decade counter. This circuit is powered by a 417 chip. This chip takes the clock signal from the NAND gate oscillator and divides it among 10 LEDs. The pace of the counting can be changed by using a potentiometer to alter the resistance in RC2. Next, the decimal counting binary up-down counter. This circuit features the 4510 chip. This circuit takes the carryout of the decade counter and turns it into binary counting. This circuit can count from either 0 to 15 or 15 to 0, depending on how it is conditioned. It represents the numbers in binary. The final chip of the counting circuit is the binary counting decimal decoder, utilizing the 4511 chip. This chip decodes the binary output from the decimal counting binary up-down counter and turns it into decimal so that the 7-segment display can display it. Next, the 7-segment display. The 7-segment display is responsible for the visual display of the counting circuit. This 7-segment display is common cathode. This means that it shares a cathode lead, or a voltage out lead, and has separate anode leads, or voltage in leads. Next, the counting circuit PCB. This transfers the breadboard prototype to a permanent PCB setup. This PCB requires the soldering of many materials already in the circuit. It adds a 100 microfarad electrolytic capacitor, 2 resistor networks, a terminal block, and a 0.1 microfarad capacitor. Finally, the encasement. The encasement is a 3D printed encasement custom made for this PCB. It has a compartment to hold the battery so that it does not need to be plugged in. This is the final step to the counting circuit,